Good morning to all of you. Now we are going to discuss about conditional probability. The probability of happening an event A while another event B has already happened is called the conditional probability of A such that B has already happened. It is denoted by probability of A given B. Let us take the classical definition of conditional probability. Let A and B be two events associated with the same sample space, then the probability of occurrence of A under the condition that B has already occurred is called the conditional probability, and it is denoted by probability of A given B, and it is defined as probability of A given B equals to probability of A intersection B divided by probability of B, such that probability of probability of B does not equals to 0. Similarly, we can define probability of B given A equals to probability of B intersection A divided by probability of A, such that probability of A does not equals to 0. Let me discuss some properties of conditional probability. Let A and B be events of a sample space S, then number 1, probability of S given B equals to 1. And number 2, probability of A union B given C equals to probability of A given C plus probability of B given C minus probability of A intersection B given C, where C is any event of S. And number 3 is probability of E dash given F equals to 1 minus probability of E given F. The proof of these properties are available in any books of probability. Let us take an example. A pair of die is thrown. Find probability of B given A if the event A is 2 appears at least in one die and B is sum of numbers appearing on die is 6. Here see that if we throw a die, then we get the total 6 possible outcomes, and if we throw a pair of die, then we get total 6 into 6 equals to 36 possible outcomes. And in that example, even A is what? 2 appears at least one die. Therefore, A takes the value ordered pair 1, 2, 2, 1, 2, 2, 2, 3 and so on. And B takes the value ordered pair 1, 5, 2, 4, 3, 3, 3 and so on, as B is the event as sum of numbers appearing one die is 6. Therefore, B takes the value 1, 5 as 1 plus 5 equals to 6. And from this A and B, we get A intersection B is 2, 4 and 4, 2. Therefore, probability of A intersection B is what? Here, notice that total number of outcome is 36 and number of elements in A intersection B is what? 2. Therefore, probability of A intersection B is 2 by 36. And similarly, probability of B is 5 by 36. And using the definition of conditional probability, we get probability of A given B is 2 by 5. Here we just use the definition of conditional probability. Let us take another example. If probability of A is 1/3, probability of B is 1 by 4 and probability of A union B is half, determine the value of number 1, probability of B given A, and number 2, probability of A given B dash. We are given that probability of A is 1/3, probability of B is 1 by 4 and probability of A union B is half. Using the addition law of probability, we get the probability of A union B is probability of A plus probability of B minus probability of A intersection B. Here notice that A and B are any event, therefore we get this one. And after calculating, we get probability of A intersection B is what? 1 by 12. Now, solution of 1 is what? Probability of A given B. And using the definition of conditional probability, we get this one is 1 by 4. Let me solve the second one. This one is probability of A given B dash. A given B dash is what? Probability of A intersection B dash divided by probability of B dash. using the properties of set theory, we have probability of A intersection B dash equals to probability of A minus probability of A intersection B divided by probability of B dash, and probability of B dash is what? 1 minus probability of B, which one is 3 by 4, and after calculating we get probability of A given B dash is 1 by 3. Let me define independent event. Two events A and B are said to be independent if and only if probability of A given B equals to probability of A. That is, when the conditional probability of A given B is same as the probability of A, then we say that A and B are independent. Let us take an example. What is the probability of obtaining 6 and 6 on two successive rolls of a die? And solution is what? Probability of obtaining 6 on a roll of a die is 1 by 6. The two rolls are independent. This the die cannot remember the happened first. What happened first? So probability of 6 and 6 is what? 1 by 6 into 1 by 6 equals to 1 by 36. Let us take another example. A box contains 3 white cards and 3 black cards numbered as follows. White is numbered as 1, 2, 2 and black is 1, 1, 2. One card is picked out of the box at random if A is the event that the card is black and B is the event that the card is marked as 2. Are A and B independent? To solve this problem, we use a theorem like as two events A and B are independent if and only if probability of A intersection B equals to probability of A into probability of B. Here, see that the probability of A is half, because the box contains 3 white cards and 3 black cards. That is, there are 6 cards in the box, and A is the event, that is the card is black. There are 3 black cards in the box. Therefore, probability of A is what? 3 by 6, which one is half. Similarly, probability of B is also half, because 3 cards have marked as 2 and total number of cards is 6. Therefore, this one is also half. And the probability of A intersection B. A intersection B is what? Probability of card is black and marked as 2. Notice that there are only one black card, which one is marked as 2. Therefore, probability of A intersection B is 1 by 6. Now, 1 by 6 does not equals to 1 by 2 into 1 by 2. Therefore, A and B are not independent. That means probability of A intersection B does not equals to probability of A into probability of B. Therefore, we say that the events A and B are not independent. Thank you.